So this will be a series of videos to help you out with the end of the year assignment. I'm going to go ahead and blow this up just a little bit bigger here. So number 15, dealing with this deals with the fundamental theorem of calculus, based on what I'm trying to get at this point. Okay, they give you a set of conditions: g of 0 equals to 1, g of 0 equals to 1. Then they ask you what is g of 3. Okay, so the fundamental theorem of calculus would state using this as g of 0 plus the interval from 0 to 3 of g prime. Okay? And whatever it is, let's call it a g prime of x dx. Okay? So that's what that is. So what's g of 0? G of 0 is 1 plus what's the integral from 0 to 3 of g prime. So from 0 all the way to 3. If I look at this part, this area right here is 1/4 the area of a circle, okay, plus up to this point right here, half a triangle. So it is going to be 1 half, right? But 1/2 of 1/2 base times height. Okay, so if the base of the triangle is going to be 2, the height is 2, it's going to be 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Okay, so you kind of get the picture of that. That 1 plus this 1 will give you some value at that point right there. So remember, this whole thing right here I just wrote down is basically this. Okay, this is R, by the way. Okay. All right, going on to the next problem. You have to find the first derivative and set equal to 0. This will be quadratic. So that means x will equal to a certain value and x will equal to a certain value, to which the function of the quadratic will equal to 0. Okay? But only one of those values, one of the x values, will lie in the interval 0 and 6. You will test that value. Okay? So I'll call it x1 and x2. Let's say, for example, it's x2 that lies here. So I'm going to put x2 right here, for example. And I'll put a point that's 1 higher than x2 on this side and 1 less than x2 on this side. And then on this side here will be 0, and on this side here will be 6. That's the lit end. I plug in 0 and 6, and what is f prime at that point? These are x. Okay, so what are those points there? Okay, so either my max value will occur at 0, at 5, at 6, at 8. Remember, what's max value when dealing with the first derivative? That means the function was increasing, and then all of a sudden it hits the highest point, and what does it do? It starts to decrease. So you have to look at f prime and see where to go from positive to negative. That's all I'm going to say about that part. That's using your table here. Again, I'm using x2 as an example. I don't know what it's going to be to figure that out. It has to lie between 0 and 6. It could be x1. Number 19, L'Hopital's rule. Take the derivative of the top and the bottom until you have a simplified function. Okay? Until you answer. Here, you will end up with this being 0 over 0, and that's an independent form. So I can't do that. Okay? So keep taking the derivative of the top and the bottom until you know to get an indeterminate form. Number 20 deals with IVT and MVT, intermediate value theorem and mean value theorem. Okay, what I mean by mean value theorem, the slope is equal to b of 2 bless g of x2 minus g of over x2 minus x. Kind of gives you a hint, right? Isn't this what these guys are? The slope of a twice differentiable function means this is g. The slope of g, this is actually g prime. So I kind of gave you a hint. You know, using substitution, u equals x plus 1. So that takes care of this right here. So your function will look like this. X over the square root of u. What is dx? Well, I got to take a derivative of u. So the derivative of u is just equal to dx. So I can replace that. How do I get, what do I do with this guy? Question mark. Remember my substitution is called substitution now. Go ahead and solve for x, and now I have it in terms of u. I hopefully that out. It's a, b, c, or d. And notice they didn't solve for the integral. What is the equivalent? Okay. 24. Anytime you deal with a rational function, then you're asked about removable discontinuity. Rational functions need to be simplified. So I have two quadratics. Factor them apart. The numerator. Notice each one of those coefficients. Right here, 2, 14, negative 16 is divisible by 2. So I can factor out a 2 and help to factor easier. Whenever I factor, once I factor the top and the bottom, I can see what can be canceled out. So for example, let's say you notice here it says 1, 8, negative 8, 1, 8. Let's say it was 8. And what was on top was x minus 8. On the bottom, I also had x minus 8. For factorization, this multiplication factor. When I set those equal to 0 to find discontinuity or continuity points, then the one that canceled out is the one that I'm looking for to answer this question. And when I set that equal to 0, let's suppose x minus 8 equal to 0, I'm going to get 8, for example. So this could be B. That's all I'm saying. So first thing is factor it apart, okay, guys? So f of x, just to help me out right here, I can remove, or I can factor 2, so it becomes x squared plus 7x minus 16. At the bottom, this is x squared minus 9x plus 8. You just know how to factor. Helping you out with the setup, okay? Go look at that. I'll be looking at 2 in assignment 1 in a little bit. I'll give 2 more videos on